A very good afternoon to all of you. I think I can speak in this, okay. So, respected Chancellor, Assam Royal Global University, Vice Chancellor, Vice Chancellor, and I have seen many distinguished Vice Chancellors from other universities, faculties, and ladies and gentlemen, and my dear students. So, I feel very proud to come not only to RGU, but to deliver, the first Professor M.K. Chaudhuri Memorial Oration. So when Professor A.K. Buragohai sir called me, and he asked me to present the first, the oration on his memorial. So, the first instance, come to me is that, I feel, so much happy and, excited because of the one reason, that is that, I always like, science. But people like sports, people like, music, people like any other extracurricular activities. But, I feel Professor MKC is a celebrity in science. So, we always, like to see the actor, sports person, and treat them as a celebrity. But we never treat, we never like, feel that, the scientists or the academicians as a celebrity. So at the first, let me pay my tribute to this Professor M.K. Chaudhuri Memorial Oration, and also to the family members. So as the Chancellor has told few of the story, I think many of us has several stories with Professor M.K. Chaudhuri. He's such a, impactful person, particularly in the field of science and education. So for the first time, I heard about you, as Chancellor, respected Chancellors are also told. So when I was studying BSc in chemistry in DR College, Golaghat, so one of my assistant professor, he told me that there is a person, there is a scientist, there is a professor. He came to Dibrugarh University when he was studying MSc. So he was narrating in such a way, so at that moment, I'm feeling like, the science should also can become a celebrity for someone. She is celebrating, he is discussing in many ways. Like that, this is my, if I say honestly, it feels that he was like a hero of any movies. So, and the second time, in my case, in personal, achievements, if I say, or in personal scientific careers, he was my mentor. I worked at TESP University for a few years, but those few years, Professor Buragohai sir also was at that time as a registrar. So those few years, he was, mentoring, many of the faculties or students. But in my case also, I was getting a lot of inspiration from him. So I got, just for benefit of the students, I was working as a research scientist or research associate, not like faculty, equivalent to faculty position. So I got a fellowship in Indian Institute of Science. So in spite of, looking the, the background, he always, wanted to look the ideas and how ideas can become, knowledge can become, if directly say the development of a country or region. So in that way, he inspired me a lot of. And finally, just when I was coming from Jorhat by in car, the things came into mind. Otherwise, I could not speak this in front of, particularly for the young faculties and students, research scholars. When I was working on CQD, I will speak because, of course, it's a memorial oration. But as a scientist, I will show my journey how science can be cultivated in this region. So when I was working in carbon quantum dot, one day one scientist, he told me that why don't you do this? Then I told him, what is the basis you are telling me to do this, or how I can make the science to technology, technology to the commercialization commercialization to the economic benefit. As in the introduction, the lady told that 20% cheaper technology than the existing one. So then the scientist referred the name of Professor MKC, that he has done, he has transferred his knowledge into, he's translated his knowledge into technology in this way. So I am not, I'm very happy to say that I followed the same things in my research, and I got success. And this I told him also. When I got the SSP prize, he called me the same day on 26 September. Then he called me, and then, as I would like to say that how humanity, how the sense of humor he has, he told me over phone that you got the SSP prize, but it is not your prize. It is not your achievement. It is the achievement of your parents. It is the achievement of your grandparents. It is the achievement of your family. You see, so when we become success, we think that we got everything. But he told me over phone, Binoy, you have to now do for the people. You have not received anything. This is a achievement of your parents, of your students, of your others. So such kind of person, I'm so much happy. So I, with permission to the RGU, I got this slide from a Facebook page. So when he joined in our RGU, this image was there. I think 2017 or 2017 someday in June. So I think, so in this, as a symposium or oration, I think definitely there are few research scholars, there are scientists or the academician. So let me go into my journey, how science, how ideas can be implemented, and what are the obstacles, and how we can, do something for the people. So science and society is a very, very important relationship that we have to understand. So basically, as this is, common audience are there, so I think that is why I made few of the very common slide, but also the technical side, but I will skip it. I will not take so much time on that slide. So basically, the one of the most, major problem is the CO2 emission. So how, our science can contribute. Suppose we are working on, as MKC sir was working on catalysis. So this would again remind me one of the things I think every faculties or students can recognize at that time in maybe after 2000 years, 2000 in this academic session, there was one complex, copper acetyl acetone complex, iron acetyl acetone complex. Those complexes are developed by Professor MKC. Just for information to young students, so those complexes we have prepared in our master degree courses and BSc courses, but those are developed or discovered by Professor MKC. So how we can go, how we can do something for the reduce of CO2 emission. Okay, so I think I will not go details, but we always, our government policies, our political agendas, international agenda, there is always one thing, the CO2, to reduce the CO2 emission to have a net zero emissions. So the culprit is the carbon, sorry, I should not say culprit as a carbon, but because carbon is also beneficial for us in daily life. We are using mobiles, laptops, and sports items, a lot of carbon, but it is also culprit because if carbon burns, it gives CO2. The very simple equation, but the danger is that it releases CO2, which is not required, but also it is required in other cases. But for the human to sustain for longer life, we have to reduce the CO2. So it is increasing. It's a very high energy reactions. So CO2 is increasing. So how to get rid of it? So, but why CO2? Why government, political agendas and the ministries, all are bothered about the CO2? Because it is related to GDP. So this is, last month I was looking why CO2. Our Honorable Prime Minister also, targeting to reduce the zero CO2 by 2070. So why? Because it is related to GDP. Because any country, its GDP is related to CO2. If there is lower emission, the GDP will grow. But in case of India, it is both are increasing. So this is an difference with the other states. In India, GDP as well as CO2 emissions increasing. You can see the last graph. So, so as I told, the government agendas are there. to reduce the CO2. They are going for the conversion, utilization, or the improvement of energy. Even implementing the electric vehicles. A lot of environmental policies by the Ministry of Environmental Forest. But basically, the two things: the battery storage and the carbon conversion. This is also in the agenda. So we have to go towards the battery use, and minimizing the fossil fuel use. So that is the thing. Whatever we are doing, we have to see how we can reduce the use of fossil fuel and the petroleum, crude oil utilization. But the carbon, I think it's a very simple slide. Carbon is everywhere. We cannot ignore it. We have to intake the carbon in different forms. So, but some of the forms of carbon is seems to be difficult for us, like coal, the graphite, the biomass, or the other synthetic sources. So those carbon we are taking in a different way, but these carbons, people are burning for utilizing the energies. So this is the difficulty. So as as you know in my introduction that I am working on coal. So coal is a form of carbon. So that carbon, if we burn it, then we got energy. This is true and this is required for us because 70% of electricity is generated from coal burning in our country. But in different way, it also polluting. So what to do it? So in that direction, my research particularly is moving, and so the energy is also required. You can see how the energy consumption is increasing. We're tremendously increasing in different forms. So what to do? We have to take the energy from those sources, but in another way, alternative development is essential. And if we see the industry also, you can see year by year it is increasing coal use, oil, particularly for the few of the countries, actually, US, Germany, they have stopped the coal combustion, but few of the countries, they cannot. India, we have to depend on coal for, I think, several years, in many years to come. Because, we have enough coal resources and we are also targeting the clean technologies to utilize the coal resources. So if you see the CO2 emission, it is also very dangerous. Most of the countries, particularly China and Russia and India, they are in a very, very high CO2 emission ranges. So that is why the other countries, those have reduced, banned the coal combustion or the biomass combustion. Those are in a far better place, but in case of other countries, it's very, very to be think for. So how to recycle carbon? That is the reason. So I thought that. So these ideas came to me that how those carbon can be alternatively utilized and in other direction to minimize the CO2 emission. This is the mechanism. So it is very, very essential because it depends on economy, I told. And it is also, is a very hot areas of different, several countries in their GDP as well as the circular economy business. So then I look into that, what people are doing with the carbon. So then I found that few of the companies, including the Indian companies, they are now moving towards the circular economy of the carbon. That is carbon conversion. Carbon is converted in different form in which CO2 emission is reduced. So I found, like in Unilever, Indian company, they have targeted by 2025, they will use 100% carbon material in their product. So those things are there in the business. So this is an very luxurious car. I just found, my research scholar gave me this slide. So he told me that this Bugatti, all the parts of the car is made of carbon, and they got a profitable business in their market by utilizing those circular carbon economy. So that has to become to country. But carbon is also the Nobel-winning innovations, particularly for the students and research scholars. You see, till now there are 3 Nobel Prizes has been given to the carbon. So the first one, we can see in the fullerene in 1996, it got Nobel Prize for fullerene. Fullerene is a carbon allotrope, carbon form. Then later on, got the graphene, the miracle material of carbon. So they also got the graphene. And then we got the carbon, quantum dot, not carbon, but carbon quantum dot is also a family of quantum dot. So the carbon research is also worldwide very much going on, and people are interested to use the carbon in a different way. So this is just to give a brief, slide. So this graphene was, the idea. That is what, in the first instance, as the speaker have told, that the idea become the future. So in this case, graphene synthesis or graphene extraction is an idea. So that graphene extraction idea becomes the novel idea, and now we are getting the benefit. So in our case, those carbon resources are utilizing in our daily energy production. So what to do those with the carbon resources and to minimize the CO2 emission. So in this case, as a coal, I think few if geologists are there, few of the the coal is, we treat it as a fossil fuel, but it's a tremendous source of carbon. So when I joined in 2011 as a scientist in CSIR, people are working in a carbon, coal beneficiation, coal utilization, coal gasification, coal liquefaction, those things. So, but nobody is looking on the carbon, how that can be recovered to make it a value-added product. So then, we started to looking into the carbon conversion of coal. Then we got success because coal has those, chemical structure. Although it's a very, very, complex and heterogeneous structure, but that can be also break into smaller atoms. So in this case, this data actually, we have to do a lot of calculation on LCA and the impact analysis. But with the help of our last year Nobel Prize winning, AI, so I found, I just put my work. Then AI give that, if we traditional coal use have 2.5 to 3 million this CO2 emission per million tons. Okay, I forgot this. Per kg, but our work, this is an AI generated data. It gives 1.2, reduced to 1.2 million ton of CO2 emission per kg of coal. So it gives, it shows that yes, if we continue such type of ideas, then definitely it could have a very impactful impact on the climate effects. So I think these few of the technical slides are there. I will just give the ideas. The carbon quantum dot is also one of the, very, very greatest and very, very futuristic carbon material. Basically, it is used in, medical science, sensing, white light LEDs, LEDs, and also the water purification. Tremendous applications are there in security. But the thing is that, the synthetic process and the this price is very high. If we see the price in the internet, like India Mart or Sigma Rig or many of the supplied in India, we'll find that 1 liter is approximately 1 lakh or more than 1 lakh rupees. So if we can have those large amounts, what to do? So those things, we thought that we can use those coal resources to make it security and also to not to burn it for making the pollution. So this is a process we developed from coal to CQD. It's a very, very simple process. A layman can do it. If you just need hydrogen peroxide and stir it and filter it, and you will get an abundant amount of CQD from coal. It's a very, very simple process. So we have patented it in India as well as in US. US it is granted. And this is also transferred. So these things, yes. So so these things, when I developed this technology, then I was thinking to transfer. Because our scientists, we usually develop, we do some experimental lab and make it a technology and then transfer to some companies like startup or some companies. But I find that the startups is basically the material startup are very, success rate is very, very low. Only the AI or IT-based startups I found is very more than 90% success. But if we go for the material startup, the success is very low. So I could not find a parties to transfer it. I inquired, a lot of Indian companies, but they are not interested. So then Professor MKC's idea came to me. So that scientist told me, why don't you adopt this procedure? So what is the procedure is that I talk to US companies. That is Sigma Rig. So I talked to Sigma Rig, and when I just drop a mail to Sigma Rig, so one lady, she is CTO of the Sigma Rig, she called me over phone. After 1 hour or 2 hours, she called me after phone. That's very, very interesting. Can we have an audio call or video call meeting? So then, we got 3-4 times conversation with the Sigma Rig, then they're interested. So this idea, actually, I told already when he was, he was, that I discussed this matter with you. So he was so happy that, yes, this is the way how we should go to the approach these things. So then the Sigma League took the technology and from us that they have given 3 years license to manufacture in different countries. So then this is, was just for technical. Those are CQD. I think basically CQD is a very, very small nanocrystalline carbon. So it is the magnificent properties that it gives color emission when exposed to external source of light. So it is colorless, but if in presence of external color like in laser or UV, it gives a different color emission. So that is the beauty, and that is the property it can be used as in diagnostic applications. So I think we have tested in different because CQD mainly the biomedical or biological applications are there. We have studied their toxicology and a lot of other. This I will not go detail into that. Then we also tried in cancer cells, but this study, because being a chemist, I have to slow it down. But it has a very, very future properties. I asked to the biologists and biotechnologists to look into this, because we have got a lot of activity with the virus and other cancer cells with this coal-based CQD. And then the nanodiamonds. Nanodiamonds is also one of carbon form, and is a very, very diamond. All we know diamond is how important to the women and to the as jewelry. Very, very decorative and luxurious item. But nanodiamonds is also very, very luxurious item to the science. So this is different to the CQD is that it has 2 types of carbon. So CQD have sp2, but it has 2 types of carbon. So that has to be optimized. It is also very costly. So we try to see whether those coal can be converted, or coal-based material can be converted to nanodiamond. But interestingly, at the time, this we have the problem in Delhi air pollution. So because of in this season, current season, Delhi, school is closed because of the smoke and because of the dust, air pollutant dust. Then when I heard about carbon, then I thought, why don't you see the carbon in the aerosols, in the air pollutant? Because it's a carbonaceous aerosol. So that idea, we have started to work and found that the air pollutant can be converted to nanodiamond. It's a very, very, I can say, very funny idea. I don't know, because one professor when I presented this in Delhi American Chemical Society, the one professor was very much angry, very much angry to me, that what this idea you are giving? Air pollutant to nanodiamonds, what is this? But we got it, and we have patented it in the US as well as India. So this is an idea. So the idea is that, the smoke tower installed in Delhi by the government, if those dust can be, prototype can be developed, that those dust are converted and purified to nanodiamond, it's a very, very big idea can be implemented. So these are nanodiamond examinations by electron microscopy. I think I will not go details. We can see the lattice carbon fringes in the electron microscope. And then we also see its photo physical properties. So it is also blue emitting, and it is also the excitation dependent. And then also those, because of the, we also want to see whether nanodiamonds is useful for the biological application in cell detection or cell imaging or, cell location or the, cancer cell location on the basis of the color emitting properties. And then graphene. This is another carbon, graphene. It's a miracle material, as we know. This is also we try to develop if our Northeast Indian coal. The most important thing is that, we have to be very much, we are always thankful to God. This Northeast Indian coal is particularly useful for such technologies. Otherwise, US and China, I think nobody can, why they're not doing this. This is a grace of God, because this type of coal, low grade or the lower structure or the very easily breakable carbon structure is available in such coal. That is why we are getting CQD and graphene from Northeast Indian coal. So this graphene is a single layer, I think, as you told. So this technology also we have developed. And this is also, very high yield. You can see the 25% graphene-like material or the reduced graphene we have derived. And this is also patented in India as well as the US. But coal is, in other countries, so I patented in other 7 countries. This is very, very important. Our knowledge will be protected. So that's why we file patent in Australia and South Africa, China, as well as in other 7 countries. So this is a very simple step, except the filtration. So this is the science, the most science behind in the filtration. We have to have the size of the graphene structure. So these are the characterization. I think if you can see the Raman spectra of the graphene layers. It is not a single layers, of course. We go up to 2 layers. But if we can get a 1 layer, that is great. But we can achieve up to 3 layers or 2 layers of graphene material. And the most important, particularly for the students, and I would like to state that, if you develop something, as Professor Amkesi sir has developed the copper acetyl acetate complex. So what is the benefit? So this is introduced in the text, in the syllabus, students HRD development. That is the impact and the test bed evaluation. So we have developed graphene. So what it is? Graphene is there in the market. We use the graphene to make a battery, supercapacitor. Then what? Then after making the supercapacitor, we have also demonstrated the powering of a light. So it should go to the society. Such kinds of inspiration can be achievable from people like Professor Amkesi. So the test bed evaluation is very, very necessary. So you can see that how we have tested our product in the final applications. This is very, very essential. These are coin cells. Those are the pouch cell. I find that pouch cell is not available in market. So we make the pouch type prismatic cell. Then with coin cell, this is better used in our clock and other devices. And the final carbon is that then we see that coal itself is a fuel. It's an energy. But can we use it in electric vehicles? Because electric vehicles is our next generation product. So we try to see those batteries and supercapacitor in electric vehicles. So we developed carbon, activated carbon out of coal by chemical process. So activated carbon is a very simple, everybody is working on activated carbon. But thing is that how we are utilizing the activated carbon in devices. So we have a facility in our NEIST Jorhat. We can make a batteries and supercapacitor. We have a workshop. I invite students, if you come, you can see it there. So we made this such kind of pouch cell. Then we, as I saw, you can see that we have used 2 power generate powers. Then we made the pouch. If we have to go for higher current bearable capacity, we tested for 20 amperes. Then we also compared with the commercial one. That's very important. If we go for testing or application, then we have to compare with the existing one. The commercially available supercapacitors, commercially available batteries. What is the difference between these and your product? So we found that we are at a considerable range of its specific capacitance or power density or energy density. Then we made out of pack, because if we go to the high-end application or high energy application, we have to make a pack of it. So we made a pack of it. We tested in a e-rickshaw. So 3-wheelers. For the timing, we were not possible to go for 4-wheelers because I visited IIT Madras and I seen that the battery of a bus is, I think 20 people seen in a bus. How big is that? But for our laboratory condition, we have tested in the 3-wheelers. And this is an indigenously coal-based supercapacitor, which is hybridized with a lithium-ion battery. So thing is that, battery can run a vehicle, but the technologists are trying to incorporate the supercapacitor to give the instant power, particularly in the hilly regions or in the braking system or those cases, we need instant energy. So that instant energy deliver can be achievable by the supercapacitor. So this is the idea. It is funded by the Ministry of Electronics and IT. I have a short video, I think that will be benefit, is full. Only 2 minutes. You can see how, the hybridized battery can be useful for our e-vehicles.
electric vehicles are becoming increasingly popular as a greener alternative to traditional gasoline vehicles. In India, electric vehicles are making their mark in the form of e-rickshaws, three-wheeler vehicles used for last-mile connectivity. However, e-rickshaws face challenges, such as limited charging infrastructure, high battery costs, and battery disposal issues. They also suffer from the fundamental drawback of insufficient on-demand power delivery during acceleration and braking, resulting in inefficient operation and reduced battery health. To address these issues, researchers led by Dr. Binoy Kumar Saikia from CSIR, Northeast Institute of Science and Technology, India, have now developed a hybrid battery pack that solves for these issues by combining two types of power sources: coal-based supercapacitors and lithium-ion batteries. The electrode materials of these novel supercapacitors are made using carbon recovered from low-grade coal feedstock. This ensures that the coal feedstock, which is commercially insignificant and causes pollution if combusted for thermal power generation, now has a sustainable alternative use in the electric vehicle sector. And consequently, supercapacitors become more accessible and affordable than those currently in the market, which are made of imported materials. Supercapacitors are energy storage devices that enable a higher power density and a faster release of energy than rechargeable batteries. In this study, Dr. Saikia and his team from CSIR NEIST, Jorhat integrated their indigenously developed coal-based supercapacitors and a lithium-ion battery, forming a powerful hybrid battery pack. This innovative hybrid battery management system allows the lithium-ion battery to be charged and discharged in a controlled manner, while using the supercapacitors as a buffer for instant power needs. During testing, the new hybrid battery pack exhibited higher power and energy densities compared to that of traditional e-rickshaw batteries, enabling e-rickshaws equipped with it to achieve increased top speeds, reduced charging times, higher load capacity and greater mileage, and opening up the possibility of its upgradation for other electric vehicles. To commercialize the coal-based indigenous supercapacitor, CSIR NEIST have already partnered with startups and industries, with the aim to enhance the cost-effectiveness and battery life of Indian e-rickshaws, thereby contributing to the alternative utilization of Indian coal and a sustainable and eco-friendly transportation ecosystem in India.
Thank you. Thank you very much.